Today we are going to cover the basic concepts of blockchain. We are going to go slow because some concepts, as I've seen in my career as well, create a lot of problem when people who are new to blockchain try to learn it. We'll go slow. We will take a look at the types of blockchain there are. This, I believe, out of the four kinds of topics or collection of topics you can see on the screen, the second topic is one of the very most important ones for you, considering that you are building products and startups using blockchain technology, possibly. So this will tell you that what kind of blockchain exactly to use. If you choose an incorrect type of blockchain, the solution will not be that great. In fact, you might not even be able to solve a particular problem. So that is very important. Next, we will also take a look at basic of public and permissioned blockchains. We'll take a look at nodes, network, the kinds of incentive mechanisms that are there, and also the kinds of attacks that can happen on such incentive mechanisms. Also, we'll take a look at some enterprise applications on blockchain that have come to being. Additionally, in addition to that, I have also increased this lecture to contain certain a few slides on in case someone wants to look further into blockchain technology. Towards the end, if we get time, we will definitely take a look. Towards the end, I have those slides, and as to how if someone wants to go further into blockchain, learn blockchain, what should be the path to learning blockchain. I've put that out. Apart from that, I've also put a few slides on generations of blockchain. If these are all topics which, if we get time, we will cover. If not, maybe we can try and set up another lecture to cover the second part of it. However it suits, we will go ahead and we will try it out. But what is there on the screen right now, these four types of topics, this is for sure is something that we are going to cover 100%. All right. So that is the purpose for the next 2 hours, and eventually the key takeaway from this blockchain lecture for you all should be to understand that how to implement blockchain in your solution, how to build high quality products in blockchain technology, using blockchain technology across anything. So I heard someone is doing something in agriculture and so on. We ourselves are an agri company. We are an agri fintech. We provide loans against your commodities, your grains, right? But we are using blockchain. That system is being used by farmers in India, and that is one of the and we are one of the largest and the first such blockchain platform in the country. So we never believed that we would be making farmers use a blockchain technology. Many a times they don't even realize that what they are interacting with is blockchain, but they are happy to receive the benefit at the end, right? So that is the goal. As a quick way of introduction, um, I'm an entrepreneur, blockchain entrepreneur. I already told. I was previously at an organization which is also an Indian unicorn. I was their product guy, and apart from that, I have been an author and also of 4 books now, and also I've been a speaker at a few of the conferences till now. In fact, the first one that you see here, Decentralized 2019, one of the speakers in that conference was the father of blockchain technology, Dr. Scott Stornetta. And this same lecture, or this similar kind of technical, non-technical basics, all these lectures that I've given to more than 4,000, 5,000 students and faculties and PhDs till now. Hence I believe that I definitely would be able to add some value to your lives over these 2 hours, and at the end of the lecture, you will be understanding something more than what you do right now. So that will be my agenda, and if anything else that comes in between, please shoot a question at me, and I'll try to address them as much as possible as well. So let's take a quick look at what we are going to do today. First of all, why is the question that we are going to answer. Why blockchain? Why decentralization? Why the thought of removal of centralized systems and bringing in decentralized systems to almost every other deployment? Why did this thought come up in the world? So we'll take a look at that. Why did decentralization take the center stage? We will also see a couple of facts which are really motivational and inspirational. Looking at that, you understand that what kind of future blockchain has, and whether blockchain is a kind of technology you should choose going ahead. We will take a look at the basic concepts, which I've already told you, that the very basic and the most important cases. However, we'll take a look at a couple of use cases and more if time permits. And lastly, this lecture should also prepare you to attend maybe further technical lectures, or maybe more detailed lectures in blockchain technology in future. This will form the foundation. So I am going to make sure that this is as much value add as possible. Alright, so you are part of this entire incubation program. So that is something that you are going through, getting a lot of benefit from. Just make sure that this lecture also does benefit you in that journey. So this lecture has been designed in a way with Africa Blockchain Institute, with Tech London, to make sure that the value you get out of it is absolute, right? Oh, okay, my bad. Is it fine now? Kevin, Mr. Kevin, is it fine now? Can someone confirm whether the screen sharing is fine now? I didn't understand what the problem was, but okay, I get it. Yeah, is something like this okay? Mr. Kayode, is the screen visible?
For my side, it's okay. It's
okay, I can
well.
see. Okay, thanks a lot for confirming. A couple of people have confirmed. Great. All right, perfect. So that's what the agenda is, and that's yeah. So yeah, so you have this entire incubation program. So we have designed this lecture in a manner that that is going to make sure that you're able to build on blockchain technologies in future. Yeah. Perfect. So okay, before we begin, let's pause here and once. So two things that I want to clear out as we go into this lecture in the next 1.5 2 hours. One thing that I want to clear out is that sometimes it might happen that I may go very fast. In the past, as I said, I've taken this lecture for 4,000, 5,000 people, and many a times a common feedback has been that, out of passion and excitement, my speed has been outrageous. So if that happens, the goal is not for me to cover 100 different topics. The goal of this lecture is to make sure that at least a percentage of those topics gets across properly. So in any case, if my language is not clear, my language is fast, or lecture is going very fast, please out of all these people we have here, Mr. Kayode or anyone from the participants, please do write in the chat so that I slow myself down. It is something I know might happen, so please do let me know. Another thing, whenever lectures have stretched for over 1.5 2 hours, one feedback that I've got is that I have never taken breaks in between, never given breaks either. Sometimes I've received a feedback that a break is needed to grasp things properly, to stretch yourselves out and all. So what we'll do is we are starting at it's 2 p.m. IST in my clock. I think it's somewhere around 11:30 or so in your clocks, or 10:30 on your clocks, I guess, right? So we'll take a break for 2 minutes, a bio break, stretch your legs break, for just 1 or 2 minutes, because we have a lot to cover. But still, we'll take a short break around you can say 1 hour or 1 hour 15 minutes later, and then we'll cover another hour after that, right? So I'll let you know once I have that break in between. Yeah, so that's all. So let's get ahead. So remember, this entire blockchain skill, this is one of the data points that I wanted to share. Blockchain technology as a skill was ranked number 1 by LinkedIn in 2020 itself. Skills such as cloud computing, artificial intelligence, which have been individually on the first position for quite some time now, they were ranked below. They were ranked 2 and number 4 respectively. So you have to understand that just within a decade or so, just 11 years, blockchain has come out to be such an important piece of technology. That is very important for us to understand that where things are moving for blockchain technology. And it's not just the Bitcoin price that is moving, it's the usability of blockchain technology across use cases: fintech, agri-tech, insurtech, regtech, health tech. All these areas are seeing immense uses of blockchain technology every other day. So that is something that we have to keep in mind. To support that, one data point here is, and this is by the CEO of Randstad India, is that salaries of ready to be deployed employees with blockchain experience were twice than that of an employee without this particular skill. This shows you that blockchain people are earning way more. So in case you are running a startup, you have to be very well aware. This is one data point that is comes as very different for employees who are have blockchain skills, and founders who are looking to hire blockchain engineers or blockchain product people or blockchain business analysts, right? People with blockchain skills, they will cost you at least 1.5 or 2 times as much. This is a very important point for you to keep in mind. Personally speaking, I have one blockchain engineer position open at my company. We have filled so many positions during the COVID months, but one position of blockchain engineer has been open since 4.5 months, and I have not been able to close because the kind of either the budget or the skills do not have a match, right? Either if the skills are great, the budget we are able to afford, it goes high, right? So it is one of the real experiences that I can share with you, that these employees are coming very highly priced. Right, so that was the couple of data points I wanted to share. Now we go forward and we set up ourselves to understand blockchain technology as a whole. Let us try to take an example, a very common example. I have given this example, taught this example always, and it has put the thought across. Let us say that I have $100. I want to pay Mr. Coyote that $100. I do that. My bank writes it's in its ledger that Abhishek gave transferred rupees $100 to Mr. Coyote. What happens tomorrow? And if Mr. Coyote has the same bank, then that's all the ledger that has been updated. If Mr. Coyote has a different bank, then 2 different banks are updating the same ledger, their individual ledgers. What happens if tomorrow morning I wake up and my bank, and I look into my ledger and my bank says that no, you never did any transaction of $100, and we don't have any history, but yeah, your $100 is not visible in your account. I will have nowhere to go to claim that $100 back, because there is no other proof. Yeah, of course, I can go, I can tell the central bank, and a lot of things I can do as a way of resolution. And also we know that, popular banks in our country, they will never do this kind of a thing. But that is the kind of trust we are building in the centralized systems of our world, of our lives. That is the exact reason why decentralization came into being. What happens in decentralization? Let us assume the same concept in a decentralized world. It is very simple, direct, straightforward. The same transaction that I did for $100 to Mr. Coyote, if I'm in a decentralized network, I tell it to my network that I did this transaction. What happens is that my network contains 10 different nodes. It's not technical, I'm not going technical, just touching on a particular point. Let's say that there are 10 different people, which are nodes, but let's call them people. All of those 10 different people will write this in their ledgers, respective ledgers, that Mr. Abhishek gave $100 to Mr. Coyote. Now, if something like the earlier example of my bank happens with me, say for example, one of the ledgers do not have my entry, or has removed my entry, or has done anything to mess up my transaction, 9 other people or 10 other people or 8 other people will immediately call that person or that node or that ledger out, that hey, why is your ledger not matching that to our ledgers, which is everyone, the transaction that everyone has, why does your ledger not have that transaction? It takes that one moment, and they can call out, and they will know, the network will know that someone tried to mess up with the ledger, and immediately a rectification would be done. Either that node would be dismembered, or or some kind of rectification can be done. And that is exactly how a decentralized network works, how blockchain technology particularly works, how blocks get made, how mining happens. All these buzzwords you must have definitely heard. We will take a look at them. We will try to understand them from a technical standpoint also. But to be honest, this is what decentralization is. Not putting one line that I want you to take away from this lecture is that decentralization is simply about not putting the control of your life, of your transactions, your money, your retirement savings, your data, everything in the hands and in the ledger and in the books and the database of one single centralized entity. It is all about not trusting one entity, rather trusting a set of 10 different nodes. It's trusting an entire network of more than 2, 3, 4 people. That's how decentralization works, and that is the core of decentralization. Why decentralization came into being in this world is simply because with decentralization in picture, what happens is that people have an immense amount of trust in a decentralized system, so that they don't have to trust a single entity. They know that for 10 people to go bad, to turn malign, is an impossible task, or is a nearly an impractical task, as compared to one entity or one organization or one individual become bad, go rogue, right? So that is the concept of decentralization as a whole. So that is one key takeaway from this. I would really want you to take that anywhere you're applying decentralization technologies, make sure that this is the point it solves. This is the reason why you're doing that. So to sum up whatever we discussed in the last 5 minutes, first of all, in a centralized world, you do not have complete control over your data. Your bank has control over that. Google.com, that kind of a company, it's a centralized company. We trust Google with almost every other data that we have. It's our location data, our food habits, our to-dos, right? What we need to do in our entire day, what our calendar looks like, how many meetings we have in a day, everything, what browsing history we have, everything is we give in the hands of Google, right? We trust Google. But what happens if Google turns bad someday? That is the only place that is going to save us, and Google itself, and no one else. On the other hand, if this would have been a decentralized network, the entire landscape would have been very different. That is it. So you do not have complete control over your data. In a centralized world and against a centralized world, you cannot trust a single entity which can any day go rogue, just as we discussed using our example. Also, the need for decentralization is the third point you can see on the screen. The need for decentralization is categorically in a place, in a sector, in a segment which segment faces adverse situations such as collusion, frauds, scams, corruption, scandals, all of these, financial scams, financial frauds, all of these, whenever any segment or any sector faces, that is the point where you have to make sure that blockchain or decentralization technology is used and to curb these things. Otherwise, you have to make sure that these are the things that a decentralized network definitely solves. So it is very important that we match the use case of where we want to implement blockchain technology or decentralization, any kind of decentralization. All right, so that is the biggest answer that we want to do, and over the next 1 hour, 1.5 hours, that is what we want to answer. That so is answer to all of these problems, is it decentralized ledger technology, is it DLT, distributed ledger technology, is it blockchain technology, right? So that is the answer that we are going to seek using our entire lecture, and I'm sure that we are going to accomplish that. Before we begin, I have 2 myths to share with you regarding blockchain technology. Before we actually delve into critical concepts of blockchain, I have 2 myths which I usually share in the beginning of the lectures, because the point is that many people in the past, even very educated people who have great computer science basics and all, such as PhDs in computer science, faculties of computer science, they have also, I've noticed in my own lectures, that even such participants have gotten some concepts incorrectly. So that is why these 2 myths on the screen. Yes, I see someone is unmuted. Is there a question? Mr. Coyote, is there a question? Can you please take a look? Okay, I think that was my mistake. So yeah, you can see on the screen we have 1 second. Yeah. Okay, cool. Just a second. The computer is hanging a bit. All right, let me move this. Okay. So as you can see that 2 myths that I wanted to share with you all. Number 1, people believe that blockchain and cryptocurrency are one and the same thing. Biggest mistake. People, especially in India and abroad, everywhere that I've taught, people have always had that notion since the beginning that what we are studying about is Bitcoin and Ethereum and cryptocurrencies. On the other hand, what we are studying about is the technology behind cryptocurrencies as well. Cryptocurrency is one implementation of blockchain as a technology, right? So that is something that we should take care very, very properly, because otherwise your entire concepts will be disbalanced, to be honest, because you will always think that we are talking about Bitcoin, whereas we are just talking about the technology behind Bitcoin, and that is the real deal. Crypto is one implementation of this great technology. Also, like many countries banned cryptocurrencies or banned such platforms which dealt in cryptocurrencies, trading, and all of that, Bitcoin, Ethereum. But mostly any government never said that they are going to ban the technology called blockchain anyhow, any place, right? In India, abroad, anywhere. So that is one critical thing that we really want to be out of the way as we go ahead. Another myth is that people believe that blockchain technology can become everything. Very important point. You can even read the example on the screen. And this is a direct example. Someone in my previous classes, actually in real life, while taking one of these classes, later came to me and said that I want to build a to-do app on the blockchain network, on using blockchain network. The point of this entire exercise is that you have to, just as I said, just 3-4 slides back, if you take a look at this had a particular slide at a point at the end that where exactly is blockchain technology more useful, right? So we have to be ultra sure that we are actually implementing blockchain technology in use cases where the need is fulfilled by one of the core characteristics of blockchain itself. We have to make sure that we are just not picking any solution and implementing blockchain technology in it just because blockchain is the hype word. If you are running a startup, so especially one thought comes to my mind. If you are running a startup and you want to use blockchain as a technology, this is a question that we faced as well. People believe that because blockchain is the hype right now, people believe that anyone doing anything on blockchain technology is just force-fitting. It is force-fitting the use case and the technology. So you have to be very much sure that when people ask you why blockchain, you should be able to answer that. For example, in our case, I'm giving you a direct example from industry. And as I said, we are running the first and the largest network in India. We can definitely put it out very clearly. Whenever we have received this question, our answer to this is that we are solving the problem of frauds in the banking industry in this particular domain of commodity finance, and we are doing that using blockchain technology. Because everyone who asks us believes that we are just using blockchain technology because it is going hype in the world, and it is the best technology to use. So hence, if you take this example of putting a to-do app on blockchain, why would you even want to do that? There is no fraud being committed when we are talking about a to-do app. There is nothing, right? There is nothing that can create a corruption or collusion or scandal or use one of the core characteristics of blockchain network in your to-do app, right? What are the core characteristics? We will anyways take a look, but let's say we all know by now, right? Transparency, immutability, anything that you put on a blockchain network cannot be changed ever. Then transparency, anonymity, all of these things when come together, that is what we don't want, that is what we want to be solved using blockchain technology, right? A to-do app needs none of these characteristics. So similarly, this is a very important point you must take care of. Implement blockchain technology only when you are very, very sure about that. All right, now we are going to start with the questions directly, the actual topics. Any questions right now is the time to answer them. I'll wait for 30 seconds. If you have any questions, it is the time. Please do ask. Otherwise, we'll start with good technical topics.
Hello.
Yes, please tell.
Okay. This is Odar. So I would like to ask if you can help me to come again about the blockchain. I was joining late. I was frustrating to join through the issue of logging both with a different login link. Thank you.
Okay, so because in the interest of time, we have less time remaining. So what I'll do is, Hodar, that thank you for your question. What I'll do is, you have not missed a lot. You have just missed maybe a couple of basic concepts. What eventually we will do is, see the slide, it is open in front of you right now. It explains, this is where actual blockchain technology is starting. Before this, we had just dealt with some concepts. So I think you are good to go, in my opinion, right? Eventually, blockchain concepts will be dealt with going forward. Right? Shall we continue?
Okay.
Yeah. But yeah.
Thank you. Can you share a full slide of it, or you will share it after?
I can share it after, not a problem. We can share
Okay,
with
thank you.
Tech London or with Africa Blockchain Institute, and you can take from them, right? Otherwise,
Okay,
also
that's
at the
great.
end I will leave my credentials. You'll have my number, my LinkedIn. I'm always accessible. So either way, the knowledge is not going to be stopped from getting to you, right?
Sure, sure,
Either
sure.
via Mr. Kayode
Thank
or
you.
via me, it is not a problem, right? Okay, so if there is any other question, you can ask. Otherwise, I'll go ahead. Anyone? All right. So I don't see a question, but anytime anything comes up, do please write in the chat so that I can pick it up right away. Okay. So let's take a look. Let's go ahead. So we wanted to answer this thing just a slide ago. We wanted to answer that why blockchain, right? Why is the answer distributed ledger technology? Let us see. Let us take care of. So these are the most important concepts in implementing blockchain or answering the question of why blockchain. Let's take a look at that. First of all, when we are talking about removal of centralized systems and bringing in decentralized systems, removing maybe centralized banks in operation and making sure that we are in using distributed or decentralized payment systems, right? So similarly, we do not want a central point of failure to be there anywhere. A central point of failure means that everything can crumble down the moment one system goes down, one computer system or one database goes down. You lose access to transactions, you lose access to all your ledgers, you lose access to any data that you had which was being kept by one entity, and that is maybe your bank, right? So that is one thing that we are going to make sure that blockchain removes completely. Blockchain distributes that failure point to multiple, right? There are so many nodes that even if 1, 2, 3 nodes fail at this moment, there will be ample nodes to take care of the blockchain network, or the uptime, to guarantee the uptime that you need from a distributed network. That is one big thing. So there are no fragile databases in question. There is nothing that is very robust. Blockchain systems are robust for these transactions. Second point is that trust. Even with blockchain system in place, trust comes before technology in business. Even when we are using our platform to give loans to farmers, eventually what the farmers believe on is the trust that they have in the person sitting in the warehouses, and not on us who are just calling on phone and saying that congratulations, you have a loan in your name, you can take it up, right? We are not scamming them, we are not doing any corruption, we are just offering a great service, but ultimately the trust is in the warehouse, right? So with the removal of centralized systems, the motive is to take that trust from centralized systems and place it in a decentralized system. And that is where many people do not understand the concept right now. They believe that it is not needed. But believe me, when things become bad, when things go bad, that is the moment where we actually need decentralization to work and to be in place. So that is very important, right? Going ahead, if you're last one very important concept is, which I discussed earlier as well, that blockchain is immutable. Anything that goes on a blockchain network, you cannot change ever. If you go online, it's public. Bitcoin is a public blockchain. You can take a look at what the first ever transaction that was done by Satoshi Nakamoto on the Bitcoin blockchain, where it stands now, where it is, how it looked like, what was the transferred amount, everything. It is visible, it is there, no one can go back in time and change it. On the other hand, if it would have been a database, you could have hid it, you could have deleted it, modified it, done anything you want with it, right? So that is one very important point that I wanted to put across. Apart from that, the fact why blockchain network is practically hack proof, because scams and scandals and corruptions can happen always, but this thing is practically hack proof is because you cannot go back and change. What is hacking, right? Hacking is when you as a partner are colluding with your partner, and ultimately the customer is suffering, right? In this scenario, the customer has his data stored across 10 different partners, for example, 10 different nodes, 10 different people in the same network. No 1, 2 or 3 partners can come together, collude and change the customer data. It will always be called out. This is what makes it practically hack proof. It makes it immutable. It makes it that corruptions and scandals cannot happen, right? One important concept here comes is that a blockchain is public. If it's a public blockchain, we will take a look at blockchains which are not public. Very important for you, again I'm iterating. There are blockchains which are public, but everything is anonymous. Now that is the whole point. People believe that when I make anything public, people will know that I am the person doing it. That is the beauty of blockchain network, that anything that you do, even though that might be public, but that is hidden behind, that is done by, categorically, that is done by an address that is 36 or 40 or 44 character long. It looks a jumbled collection of characters. You can never make out who is the person or the organization or wallet behind that particular address. And these addresses are nothing but public keys, right? Not going much technical, but that is how these things work. And it's a public-private key combination, and you will never get to know, even though you will be able to see a transaction being done between two such public keys, you will never get to know that which are the people who are behind those public keys. Hence, it is public, but completely anonymous. In the case of public blockchain, in the case of other blockchain, it is not even public, but there are much more benefits to it. Okay, I don't see any question in the chat till now. So there can be only two reasons: that either I'm going very fast and it is difficult to catch, or it is going very well and there are no questions, or it is like it is not even interesting to listen to. Please do let me know which of these cases it is, and maybe we'll course correct, right? Otherwise, we'll go ahead. So we will be answering two questions primarily going forward. Number one is what happens after you initiate a transaction exactly. Whenever you do a transaction on a blockchain network, we'll try to understand technically as well that what exactly happens. And right when you do a transaction, maybe it's a Bitcoin transaction. Let us take an example of a Bitcoin transaction, and we'll take a look at that. The second question would be that how exactly is in this process a block getting decentrally added? Why is it not centralized? Why is it decentralized, right? What is the effect of decentralization on adding of blocks? That is something that we are going to take a look at. And we are going to answer these questions while discussing these four very important concepts of how the mathematics behind the creation of a block runs, right? Okay, let's answer them. First of all, when you do a transaction, let us say I sent one Bitcoin to, okay, I have a question. I'm glad to receive a question. Finally, someone. Both public and private blockchains are anonymous, or some are not. Thanks. A very good question. So Frank, let me take this. Okay, it says that my internet connection is a bit unstable. So if it happens that I'm not audible, please do let me know. But I believe that I'm audible now. Right? So Frank, your question is very good, and I will like to take it just 3 slides later, right? I'll keep it here. Thank you so much for giving this question. I was waiting that whether something is good or bad, and thank you for getting this question online. I'll just take it up 3 slides later, because I have a slide on public and private blockchain then. Okay, let us take a look at continue to answer these questions. What happens after you initiate a transaction? Let's say I sent maybe half a Bitcoin to Mr. Coyote or to Frank, right? When I'm doing that, the point is that my transaction would immediately go into a pool of transactions, which is technically called mempool. It is just that, mempool. It is a memory pool, you can say. So it is just a collection of transactions that are pending till now. That's all. That is where it goes at the first. Then from there, what happens is that the miners in a network, they pick up the top few transactions that they like. It is totally up to their likability. They can pick up top 10 transactions, 20, 50, maybe 60, 100, anything, right? Whatever they can accommodate in their blocks. They pick up those transactions and they form a block of them, but the block is very, very temporary right now. I have another question, so ordered. Let me take it up in a minute. So they pick up these transactions, and eventually what happens is that usually they sort the transactions in the memory pool in the order of transaction fees associated with those transactions. So for example, I am doing a half a Bitcoin transaction, and if I'm giving more transaction fee to the network for this transaction as compared to the normal transaction fee that people give, there is a high chance that one of the nodes or more than one of the nodes will be picking up my transaction next, and my transaction will get processed in the very next block that is being formed, right? If it is a very low transaction fee, then there is a very, very high chance that maybe some miner can skip that transaction for now, right? And someone else might pick it, but it might happen 2 blocks later. It is very popular. It is very, very common. So That is what happens. You do a transaction, it goes to a pool of transactions, and it is ordered in the for fashion of transaction fees, and then miners pick up those transactions. And the next step that happens is that how a block is decently added. The part here is that whenever, let's take an example of the first blockchain that we got, which is Bitcoin, and Bitcoin uses the consensus mechanism. We haven't covered consensus mechanisms yet, but let us take an example. The consensus mechanism which is used by Bitcoin is proof of work. Proof of work is a mechanism where the miner is required to show the proof that he has done, that particular miner has done this X amount of work in finding a particular solution. So that is what happens next. When we are discussing that how does a block get decently added, what we are basically looking at is that a miner taking his block of transactions, and there could be 10 such miners, right? Everyone formed their top 10, 20 transactions, took them together and created a block out of it. Now the next step for all those 9, 10, 11, 20, 100 miners, it could be any number in any network. For the next task for all those miners would be to solve a cryptographic problem. And the first one to solve that problem is going to be called out that yes, you are the miner for this particular block, and congratulations, your block goes into the blockchain, gets appended into the blockchain. So that is how a block is generated. Especially, let's take a look in the case of proof of work. What happens is that in the case of proof of work, what happens is basically you already have an answer in front of you. You know what the answer looks like. But the beauty of this is that these are cryptography based problems. These are encrypted using such hashes which cannot be decrypted back. It is just a one-way encryption, right? So in that scenario, what happens is basically you have to do, the only way for you to find that answer is to do hit and trial. You generate, the miners in fact generate millions of hashes per second, and eventually minute and hour and so, and eventually they arrive, one of them would be the first one to get an answer which matches the answer that is given there. So for example, in the case of Bitcoin, it is to get a 7 or 9 such leading zeros in the answer, and there is a different problem for all blockchains. But eventual concept is that you are, as a miner, are showing the proof that you did this work, you tried those millions of hit and trials per second to eventually arrive at this answer. And that clarifies that yes, you are the person who was the first to do so, you are the miner, and your block of transactions will go as a block and get appended in the blockchain, in the Bitcoin blockchain. So it could have happened that my transaction was a part of A, B, and E and F, 4 different blocks, right? So either of them, whoever could have been the miner, my transaction would get processed. So it is very much possible that one transaction can be a part of multiple blocks which are being mined currently. But again, only one of them is going to be mined next, and once that happens, the same block of transactions for every other 9 different people will have to be removed, because they have to again be put in the mining pool and then again selected from there, because of course there would be common transactions, and those common transactions have already gone to the Bitcoin blockchain, right, to the blockchain network as a block, as a new block that happened, right? So very important concept. Let us take a question now. So Frank, again your question after 2 slides. So Haddad has asked that is there any similarities about Hadoop clusters concept, big data and blockchain? Not big data. To answer your question, there is hardly any similarity between blockchain technology and big data. If you're talking about blockchain and comparison between blockchain and Hadoop clusters are just clusters that you form of distributed, correct me if I'm wrong, I have not worked personally directly on Hadoop clusters, but Hadoop clusters is when you form a network of these distributed systems, distributed nodes, and then you run big data operations on those nodes, right? I believe this is what Hadoop cluster does. This is eventually not what blockchain does. Otherwise, blockchain wouldn't have come into existence. Hadoop clusters is what people would have used currently, right? Blockchain is totally different. What blockchain does is, works in a similar fashion, but Hadoop Hadoop clusters does not have the same features as blockchain does. Immutability is not a part of Hadoop's feature set, Hadoop clusters feature set, to be honest. Immutability, transparency, and anonymity, all of these concepts are very, very specific to blockchain technology and nothing else. And that is why blockchain technology has taken the center stage right now when we are dealing with issues and problems and economic issues where particularly these particular characteristics of blockchain are very, very much usable, which is not fulfilled by anything like Hadoop clusters or big data is totally out of the question, but not something, any other distributed system like Hadoop clusters, it is not fulfilled by that. I hope, Hadoop, I answered your question. Is it that what, yeah, all right, thanks a lot. Thanks for confirmation. So yes, we answered the questions of what happens exactly after I initiate a transaction, how does a block get decentrally added, and now we are going to take a look at a bit of the math which we're explaining. Parts of it we have just explained. We have covered that we solve, the miners solve a cryptographic problem. There is another point of distributed consensus. Distributed consensus is when I was talking to you about proof of work as a consensus mechanism, right? So consensus mechanism is basically when we try to achieve commonality, we try to achieve one decision point amongst a group that is so diverse, it is spread across the entire world, globe. Some nodes are in North America, in Africa, in India, Mumbai, Delhi, South Africa, some are in Europe, France, anywhere, right? You have to in real time be matching the decision that is taken by the group of all of these distributed systems. For that, we put protocols and mechanisms in place which are called consensus mechanisms. The only goal of consensus mechanisms, and there are plenty of them now, proof of work, proof of stake, some of you must have heard these, proof of work, proof of stake, delegated proof of stake, proof of elapsed time, Byzantine fault tolerance, which is not directly a consensus mechanism but is implemented across many mechanisms as such, and there are so many more. So eventually what happens is that the role these play is to make the group arrive at one consensus as to what is the next block that should happen, what should be the block size, what should be the number of transactions that should be put in place, what should be the transaction fee minimum, and all of these protocol level things and everything. All of this is defined by consensus mechanisms only. So now let us take a look at arriving at distributed consensus, right? We understood what proof of work does, right? We understood what mining is, how mining happens in proof of work. The mining in proof of stake or any other consensus mechanisms happens in a different fashion. We'll try to cover as much as possible if time permits. Let me take a look at this. Yeah, I have slides on that, but again, let's skip if needed. It might go a bit technical when we are talking about nodes, then witnesses, and all of that, right? Volunteers and all of that. It'll go technical. We'll try to not be technical today. And also this fourth point, Merkle trees and the unhackable truth, I will return to this because this is going to make this particular slide more technical. So I will return to this and we'll first take a look at the types of blockchain that I've been waiting to cover. Again, any questions here till the time I maybe have a sip of water? Any questions, please do post. If you want, you can even unmute and ask the questions. Apart from Frank's question, I have not forgotten that. If not, then I'll be happy to move ahead. But again, best to post your questions in the chat so that I can take a break in between and I can pick them up directly. So let us take a look at types of blockchain, right? Public blockchain, most famous, Bitcoin, Ethereum, all of these blockchains are public. You have known them for years now. People who are working into these sectors, they might be already working on Ethereum and building decentralized applications on them. All of this is happening, right? But there are many types of blockchains. Public is one. Then there is private blockchains. Private blockchains category make it very close to centralization, to be very honest. Only such organizations use private blockchains who have a mandate kind of a thing that they have to use a technology like blockchain. But then again, they are so closed-knit community as they are such a closed-knit organization, they cannot afford to use a public blockchain or even a permissioned blockchain, a hybrid blockchain, and eventually end up using private blockchain. It uses the concepts of blockchain technology, it is immutable, it is transparent within the organization, not to the public. Definitely not public because it's a private blockchain. So it has the characteristics of blockchain technology in general, but then again it goes very, very close to centralized systems, centralized databases as well. One very, very important piece of type of blockchain, a type of blockchain that is very important nowadays, has grown a lot, apart from public blockchain, is the presence of hybrid or consortium or permissioned blockchains. Just try to remember these names. These are the keywords that are used in the industry. So it's a permissioned or a consortium blockchain. Let us take a look at what exactly these do, right? And this slide is, as I said in the beginning as well, this slide particularly is very important to take a look at for especially this group to understand. As we know, let's take a look at public blockchains first, because that is what everyone or most of us, whoever is familiar with, is most familiar with public blockchains. They know Bitcoin, they know Ethereum, right? So in the case of public blockchains, there is simply no middleman. I can do a Bitcoin transaction today and no one has to come in between to even approve that transaction. There's a set of people, but not a single entity as an intermediary, right? It is anonymous. Its address is 44 character long, but no one knows which exactly is my address. Once you know that, you'll always know that this is I am the person doing those transactions. Like we know for Satoshi Nakamoto, who did the first transaction on blockchain, on the Bitcoin blockchain, right? But then again, if that happens, I can easily within a second or within a minute create a new blockchain address, any Bitcoin, Ethereum, or any kind of address, and I can use that on that network. And again, people will not know that who this person is, right? It is very easy to be anonymous on a blockchain network. However, the transactions are public. As I said, every transaction that has happened till now on the Bitcoin or Ethereum blockchain, you can right now go and visit and view all of them. What amount it has, everything is there. Now, going ahead, few pointers for public blockchains are that miners are incentivized economically. In a public blockchain, which is exactly not how it happens in a permission blockchain. In the case of a public blockchain, the miners are always economically motivated. I'll cover this slide. Can someone tell me in the chat? I mean, this is something I expect. Definitely, people must have heard. Can someone tell me in the chat what is the incentive that a miner gets by mining a Bitcoin block? What is it that it gets? Can please someone write in the chat? You have 3-4 minutes easily till the time I cover the entire slide, right? But please, someone I expect that would write the answer to what is the reward, you can say, or what is the incentive that people get by mining Bitcoin blocks, right? Blocks on the Bitcoin blockchain, right? I'm waiting for answers there. So let's take a look ahead. So miners are economically motivated, incentivized in a public blockchain. In a public blockchain, the security of the blockchain is directly proportional to the number of nodes. The more the number of nodes, it is always the most secure blockchain. For example, right now, Bitcoin blockchain is practically, theoretically everywhere. It's unhackable. It is hack proof, because there are so many nodes that the only way to hack a blockchain network is if more than 50 or 51% of the nodes on the network collude within them and they come up with something that is not good for the blockchain. In that scenario, only the blockchain would be considered hacked. But in the case of a big network such as Bitcoin, this would mean that over 15 or 20,000 nodes are there on the Bitcoin blockchain, right? Easily across the globe. This would mean that colluding between 11,000 or 10,500 such nodes to break the Bitcoin blockchain, practically totally impossible, right? That is one big factor. Okay, I finally have an answer from Frank. I was worrying. I started to worry that no one is posting anything. So Frank, very right. It is actually 6.25 bitcoins is the reward, not 6.5. Earlier in 2020 it was 12.5 bitcoins, and around 4.5 years, it avoids a bit. Just 1 second, right? All right, yeah, sorry for that. So 6.25 is this event was also called Bitcoin halving, the reward that gets halved after every 4.5 years, and that's how the protocol is built. That's how Satoshi Nakamoto had built it, and eventually that is exactly how it will happen until the reward is almost over, almost nil, right? We don't know what will happen then, but that's how the cycle is going, right? So that is exactly how things are moving, right, in Bitcoin blockchain. So that's a public blockchain. Now we understand that 6.25 bitcoins is what a miner gets on mining a particular block. But then again, Bitcoin blockchain has reached a position where your normal laptops or computers or desktops cannot be used to mine Bitcoin blocks. Hence, people who are actually able to mine Bitcoin blockchains, who are able to do those millions of hit and trials per second to arrive at that answer, basically are spending a lot on the mining equipment as well. That is one of the most critical points to discuss, right? So, but you can understand that the incentive is so high. 6.25 bitcoins means 6.25 into 40,000, in fact 44,000, or more than that, 47,000 dollars. That's huge. That's 2.5 lakh or three, like 2.2 and 250k, 300k US dollars they get at once, right? So that is the kind of incentives that such miners have, and hence people invest so much in just mining equipment, right? The third point in public blockchains is the bottleneck that is created by the transactions per second. The throughput is a huge bottleneck. Throughput is the transactions per second in computer science language. So the transactions per second is a huge bottleneck in the case of public blockchains. That is very important, because you see a Bitcoin transaction takes more than 10 minutes to happen easily on an average. So in that scenario, you have to wait a lot for a transaction to go through. We have a couple of slides here that why exactly this is a huge problem. We'll cover it then, but this is one of the biggest bottlenecks. On the other hand, let's take a look at private blockchains. Again, a very subpar kind of a blockchain, I personally believe as well. Very near to centralization. It is very less secure because again, the number of nodes are very limited in such a blockchain. But however, some positive points are that in such a scenario, transactions per second is very high, similar to centralized systems. That is why we call it, it's very near to centralization, because transactions per second is yeah. So transactions per second is practically so high, because there are not not thousands of nodes where you have to inform the same transaction that happened on the ledger and all of that, right? So it becomes very important for us to understand that the difference between public and private blockchains in terms of this the throughput, the transactions per second. If you have a necessity that I'll come to my own example, which is for the third kind of blockchain, and you'll understand then that where the transactions per second was so important for us, right? Another point of private blockchains is that it allows high privacy of data, because it is practically just available to that one centralized entity that is running that blockchain, or maybe any entities that they add on, right? And again, it is very centralized because it is controlled by a single entity. So today, if Google starts a private blockchain, it will still be controlled by Google, right? So it is again very centralized in nature. Important point now comes on the consortium blockchains, right? In the case of consortium blockchains, it is a mix of both. What happens, it is very semi-decentralized. It is very near to decentralization actually, and quite decentralized. It is secure, and it is best for organizations like us, like banks, like governments. All of them, the best case scenario for them is to use something which is a consortium or a permission blockchain. Few characteristics are that it has the decentralized network characteristics. They can, one very important concept in consortium blockchains or permission blockchains is that it can exactly be designated of what is a particular transaction and whom is it visible to. So for example, in our case, if there are 10 different banks on the platform, we can specify which particular transaction is visible to 1, 2, or 5 or 7 banks out of those 10 banks, right? That is a big motivation for organizations to use a permission blockchain. So they can use blockchain technology, but they can be very well sure that they can have complete control over who sees what kind of data, right? However, this is not as secure as a public blockchain, but very, very, very much secure as compared to a private blockchain as well. Now is the time when I would like to take Frank's question, which was both public and private blockchains are anonymous or some are not. So Frank, I believe that it is now the right time that you'll understand the answer very clearly as well. In the case of private blockchains or consortium or permission blockchains, you asked for public and private. Okay, in the case of public blockchains, it is anonymous. You already know that. I've already told it so many times. In the case of private blockchains, the factor of anonymity does not make sense. The only reason for that is to join, very important concept, please pay attention here. If I want to join a public network such as Bitcoin or Ethereum, just now after this class I can decide and I can download the Bitcoin core client and I can start, I can download the entire ledger, which is I think 200-250 GBs of data, and I can start being a part of that Bitcoin network, and tomorrow I can also be a miner, or I can easily be a node and stay there. The point here is that anyone who's doing transactions on the Bitcoin network or is a part of the Bitcoin, is a part of the public blockchain is anonymous. we do not know which part of the world that particular person comes from, who he is, what is his LinkedIn profile. We have no idea. On the other hand, in the case of private blockchains, you cannot join a private blockchain without the approval of the entity controlling that private blockchain. So for example, in our case also, which is a permission blockchain, so you have not asked for permission. I'll tell you about permission as well, same as private. In the case of permission blockchains, for example, if it is our blockchain called World is my company's name, World blockchain. When we are onboarding any bank or any government on that particular blockchain network, we are approving that particular node. So it is nothing about anonymous. We know that only this node is the one which is going to be doing the transactions. So that the concept of anonymity goes away totally. It is still a private, it is still a key, it is still a 36 or 40 character key, but we know who is behind that because we approved them, right? Even if we have 500 different banks on our platform, we would have approved those banks sometime in the past. Hence, we have a complete idea of who exactly the bank is who is doing that particular transaction. So the concept of private of anonymity is totally different in case of public and in the case of private or permission blockchains. Frank, does that answer your question, or should I explain anything else? Okay. Do we have three types of blockchain only? I did not get how they differ. What is the similarities and differences? And it would be better if you get an example of each type of blockchain. Exactly. So I tried exactly doing that. So let me reiterate over it. This might be a question by everyone else as well. So let me reiterate. So these are the three types of blockchain, right? It might be called separate. It might be called consortium. The third type, first and second, is very, very much stringent. It is either a public or a private blockchain. The third type is a hybrid blockchain. Now, hybrid can be anything. It can be a combination of 5 different features from public blockchain, 2 features from private, and then combining them together, or different combination, right? So they can sometimes be called consortium blockchains. They can sometimes be called permission blockchains, hybrid blockchains, and so on. But the type is exactly this. When you do a mix of public and private, it becomes a third kind of blockchain. But nothing more than that. You can either have either of these three, right? So that is your answer to your first part of the question. How they differ. So that is how they differ, which is on the screen currently. You can go through them, which is I explained just now, that there is massive difference between them. Public is again very much zero middleman. You can do a transaction and no one has to come in between. It is anonymous, it is public, and all of those features are there. Miners are incentivized economically. Then the nodes are so many that thousands in number, and it is a very secure blockchain. Then the transactions per second is very low, which is a demerit, which is a con, right? So these are the few things of public blockchains. On the other hand, private blockchains, the throughput is high. However, privacy of data is there. However, it is very less secure, as it is the central entity taking care of that. As I gave an example, if Google is running a private blockchain, if Google is running a private blockchain, it will still be controlled by Google, right? So it becomes as centralized as it can get. Just that it will be, because it is a blockchain set up in technical terms, it will give those features, but eventually it will be controlled by Google as an organization, right? So again, it would be very close to centralization, but not exactly centralized. So that is what private blockchains are. You can read in the center. And the third type, hybrid, which is what I believe that most of the organizations are going to use, which is in the case of anonymity. As you ask the question, there is not a concept of anonymity, because you know whom you are onboarding on the blockchain network. Unlike public blockchains, where I just gave an example that I can immediately be a part of the Bitcoin network, and I don't have to take an approval from Satoshi Nakamoto that please make me a part of Bitcoin network, right? But on the other hand, if it's a permission blockchain, it's a consortium blockchain, I will have to ask the person running that blockchain to let me in, which in our case, as an example I gave, that if any bank wants to be a part of our platform, they have to go via us. We have to onboard those banks, right? So that is one factor. And also one biggest difference, you asked that how they differ. A biggest difference is that in a public blockchain, all transactions are visible by all nodes. In a permission blockchain, you can specify which particular transaction is only visible to which nodes and is not visible to the other nodes. You can specify this. A big difference. This is one big difference, the reason why banks and all would want to use this kind of a network. So here this answers your third part. And would it be better if we get an example? Again, I gave Bitcoin, Ethereum, examples of public blockchains. Private blockchain does not have a public example like that, which maybe you everyone know. It is one kind of a deployment. So if today I want to deploy, or Google wants to deploy a private blockchain, they can do so. It would be Google's blockchain. The technology used could be Ethereum as well, right? If you search on the internet, if you go and you can take a look, deeper look, you can even, Ethereum itself is a public blockchain, but you can create a private blockchain based on Ethereum, right? It will be an Ethereum blockchain, but running on your local system or running on your network in your own company. That will be a private blockchain. So no specific example of private blockchain, like we have big names in public, which is Bitcoin and Ethereum. No such names in private, because it is a kind of installation. You take a network and you make it private to yourself, your company, it becomes a private network. So that would be an example there. For consortium blockchains, search for something called BankChain. Many banks, I think more than 100, or I don't remember exactly, but many banks become a part of BankChain, which is a permission or a consortium. It is a consortium blockchain, right? So do take a look at that. And many banks across the globe became a part of that. Indian banks, African banks, there was some bank from England, and so on. Many banks were a part of that. Our blockchain, which is India's first and biggest, as I said, in agri fintech, world blockchain is that kind of a blockchain, permission blockchain. So these are the examples. So yes, Frank, does that answer all the parts of your question? This question that you did. Please let me know if you still have any doubts. Till then, I'll take Kevin's question, which is which one is favorable. I think that is what you said. Favorable, mostly in our project, as I said in the beginning. Most probably 95%, I am sure that what you will benefit from is, again, it has to be, I have to look into your what exactly you are building, and then maybe comment 100% surely that which is the blockchain that you have to use. But I'm 90-95% sure, even without knowing what exactly you build, that most probably consortium or permission blockchain, the third kind of hybrid blockchain, is what will come handy to you, is what you will use. You will not be using, most probably as an organization, most probably you will not be using a public or a private blockchain. Private you might still use, but then you'll have to see that whether it is benefiting you or not. So I'm 95% sure it is going to be a permission blockchain that you will use. Yes. So Mr. Kevin and hey Frank, can you please tell me whether I answered the questions, or I can explain further? Okay, thanks Kevin. No, these are applications. Yeah, exactly. You answered the question, Frank. That I hope I'm pronouncing it right. Your name is Frank, right? So yes, yeah. Thanks a lot, Frank. So I hope it was clear. And for your MetaTrader question, MetaTrader is an app. It is an app. It is a completely different thing. Not something that is related to what we are discussing here. So it is just based on. It could be based on AI. Tomorrow they might base it on something else. But it is just an app, right? Underneath they could be running anything, right? So okay, yeah. Thanks a lot. All right, so let's proceed. What do I have on the clock? Okay, so I have 1 hour on the clock. So shall we take a break now of hardly 2 minutes? Let's not do it more than 2 minutes or so. Let's take a break, and Mr. Coyote, let's take a break of 2 minutes as we had originally promised, and let's return at 2-3 minutes, not more than that. What is the time in your time zone, guys?
So here,
Yeah. Okay.
This is 11:25.
Okay. So let's return at in 5 minutes then, right? I'll be here in case you guys return earlier. Please let me know, and I'll be happy to start. Right? Let's take a quick break, a bio break or whatever you want to do, and then we return and we come with a fresh mind. Just 1 second before you go, and then we take a look at further more concepts. Wherever we'll end, we'll make sure that we cover the rest of the concepts sometime else. But yeah, let's go on a break and be back soon. I'll be here all the time. Thank you. So I have 3 p.m. IST on the clock, and if you are back, please maybe raise your hands so that I know that everyone is back. We just have a
Yeah,
few.
we are back.
Okay. Okay. Hoddard, Frank, Kevin, can you please raise your hand? There's a raise hand feature, or you can unmute and tell me so that otherwise we wait.
Yes, I'm present.
Okay. Frank, Hoddard, how about you guys?
Yes,
Frank.
I'm ready. Thank you.
Frank is there as well? Okay. So I guess Hoddard is the only person not back yet. Shall we wait for 30 seconds more? Alright, till the time we are waiting, how is it going till now? Are the concepts clear? Anyone can speak? Anyone wants to share? Till the time we wait 30 seconds more for Hoddard to come out. Frank, most of the questions were from you. So how is it running for you? Any changes that you want? The way we are talking, the way we are discussing concepts. Anything? Anyone? Anyone? You guys?
Yeah, I think everything is clear. You made it very good,
Okay.
and you go a bit slow. You are not very fast. So, from my side, I don't see any problem. It is clear. Thank you.
Perfect. Thanks a lot.
What I can say on my side, okay, it's okay, it is understandable, it is, you are running so slow so that we can move together. But I have a curiosity on how blockchain technology will be implemented, or I will be using it in my project. Yeah, so I have a little bit of curiosity. I don't know what's next. I don't know. So maybe as much as we follow so wisely, I will get more. Thank you.
Sure, I hope that as well. And anywhere, any place you feel that there is any concept gap, please pause and let me know. Also, if there is any other help that you need for particularly your project and you believe that you are not able to understand, towards the end, please get in touch with Mr. Coyote or me directly anyways, and we're going to help you, not a problem at all. Right? There might be something that is targeted towards your particular implementation. We will help you, no problem. Perfect. I saw Claudine was about to unmute. Is there something that Claudine wants to say? Otherwise, we'll proceed. And I hope Hoddard is back. Hoddard, are you back? If but we have waited, so we can start.
Yes, I'm back.
Perfect.
I'm
perfect.
back.
Perfect. Thank you so much. All right. So Claudine, I hope you have nothing to say. Then I'll just proceed. So all right.
Thank you. I was just mentioning that I'm back and just following you, sir. Thank you.
Perfect. Thanks a lot. Great. Thank you so much for confirming. Let us start again. Okay, great. So 1 second. Yeah, let me open the presentation. All right. So we were here. We have done this mostly. We have understood the difference between 3 types of blockchain, and now we are going to. Yeah, let's take a look at this. So as I said that this is going to be the most important kind of blockchain for you, especially for this class. The enterprise blockchain is that we are again, delving further. We are going more. So we had 2 agendas to look more into public blockchains, which we've done. And for you, because enterprise blockchain is of the most advantage, we are going deeper into enterprise blockchain. In fact, there are 2 more slides into enterprise blockchain. So that is how important it is for you. That is how I've designed this entire lecture. So yeah, so we can see that let's take a look at some of the benefits that enterprise blockchain brings in addition to what we already saw here. Number 1, access privileges, right? So we just said that earlier that we approve nodes or companies that become a part of our enterprise blockchain network. So while doing so, we have the ability to determine that what exactly is the access that everyone will have. Someone may be able to read and write to the blockchain. Someone may only be able to read from the blockchain, right, and so on. So that becomes very important in an enterprise blockchain where. So again, don't be confused. Enterprise blockchain, permission blockchain, consortium blockchain, all of this, I'm talking about the same thing, right? These are what people will be using. So it is good to know all these terminologies, but they are one and the same thing. And what are they? They are not public or private blockchains. They are the different kind of blockchain, which is very useful for organizations, startups, governments, banks, institutes, and all such kinds of entities which cannot use private blockchain, right? So access privileges is what I was telling that You can specify that what read and write access every node has. Visibility and privacy is very much towards at the level of transactions. You can specify that, as I said earlier in this slider also, that you can specify which transactions are visible to which particular nodes, which transactions one particular node can act on, can process and all, right? So this is very, very, very important concept in permission blockchains, in enterprise blockchains, right? So for example, permission blockchains such as Quorum allow for designation of transaction level privacy. You can exactly tell that this is a loan transaction that I'm doing. I'm telling you personally from our case, a loan transaction I'm doing. This will only be visible to me, to this particular warehouse where the deposit was done, and to that bank number A, bank A, right? That's all. That is the kind of clarity that Quorum gives while implementing a blockchain network. Very, very important to note. Excuse me. So excuse me. So that is so Quorum again, a new word introduced. Quorum is a blockchain, which is kind of built on Ethereum network. It was built on top of Ethereum, but has been built as a permission network. It was built by JP Morgan. JP Morgan, if you remember, is an organization which was totally against blockchain and cryptocurrencies, but later they have now become so forward towards blockchain and cryptocurrency that they have built their own blockchain. They have sold it now. It has been acquired by Consensus, but Quorum was originally built by JP Morgan. So world uses Quorum technology, and it is a permission blockchain technology. Data and transaction storage has two types of doing. We can do data and this is very important for you again. If you have a platform which uses blockchain technology and you want to use enterprise blockchain, you have two options to store the data that you get. This data can be anything. It is not transaction data. It is data like if you're taking, say for example, if you're taking your identity documents, KYC documents from your customers, that kind of data I'm talking about, right? Or receipts that you are storing. All of this data does not need to go on the blockchain, but if you want to make it go on blockchain, there is an option. You can use solutions. I have not written it here, so I'll just tell it out. So it is better to use options such as IPFS file systems, which is interplanetary file system. It is a distributed kind of system. Also, what you can do is it does not have to be on the decentralized network. It can be on something like AWS S3, which is the simple storage solution, right? That AWS provides. So you can also do it there, and there is not at all a problem in storing this kind of data. It can be referenced in the blockchain network, but it does not have to be present on the blockchain network. So data and transaction storage, you have ample opportunities. Execution and mining. Just in 2 slides later, I'll discuss incentive mechanisms in a bit more detail, but here is something I want to cover that very, very importantly, so for example, you can say, when we were taking a look at public blockchains, you remember we discussed that public blockchains miners are economically motivated. In the case of permission blockchains, that is just not the case. The cases are, for example, either that is, it can be anything apart from economically being motivated, such as better business processes, reduction in the time taken to deliver a service, and so on. Might get a bit complex, but that is how it is. I'm trying to make it as clear as possible. But again, we'll if there are questions, happy to take them up. But that is a critical difference between public and private and permission blockchains. Public blockchains, miners are motivated just by economic means, that I'll get Bitcoin in return. In the case of permission blockchain, see who are the members of the permission network? Banks, in our case, banks and us are the network. So we do not have any economic advantage from there, right? But all we have is that, okay, I'll do a loan transaction so that my customer gets a loan very fast. That is the kind of advantage or incentive that I or a bank would have. An example, right? So execution and mining is handled in that fashion, and there are different consensus mechanisms here. We dealt with so many, like proof of work, proof of stake, and so on. We discussed earlier a bit. There is a transaction mechanism. There is a consensus mechanism called Raft, which is used by Quorum, and such mechanism exists for permission blockchains to use, right? So that is one example. I have specially put this slide to show you exactly how you can go about designing a private or an enterprise blockchain tech stack. See, I have written here enterprise or private. So this is valid for enterprise or private, not directly valid for you can say public blockchains, but private and enterprise, they come about the same thing. So you can use this tech stack. What can you use? Let's see the 4 parts that any kind of software or application has. This again, these slides are very important for you. These are more important than any of the initial slides that you saw, because this is, I'm telling you, if you plan to use blockchain in your solution, this is what you will be using. Again, you will 95% sure not be using a public blockchain, right? So let us try to differentiate between the various parts that a particular app, that a particular panel or your entire product, if it is maybe one app or 5 different panels, or maybe distributed across 2 different customers, one has an app, one has a panel, like us, we do. In that kind of a scenario, let's try to differentiate between the various types that we have. First of all, there would be an interface, there would be an app. This has nothing to do with blockchain. It can be any mean stack, MERN stack based app, which is Angular, which is React, and these are all these languages that you use to develop the front end, right? Not at all a problem. You can build applications on these languages. It does not have to have blockchain in them. On the other hand, going a bit further, the most important part here is, one of the most important parts is the service part of it. Now this needs to talk to the blockchain, right? And also it needs to talk to the front end. So this can be custom business logic, which you can build on Node.js. You can build on any kind of such solutions. These are maybe out of scope of this lecture. It will be a technical lecture altogether. And you must be already having developers on your team if you're planning to develop applications. Like we have an entire blockchain team. So this is the part where they come into picture and they make sure that things are running very well in the place. And for that you should have a great team, because it is not everyone's cup of tea to understand and deploy blockchain based applications. We do it really good, right? Because we have important clients in our network. We have banks and the government. Anything that goes wrong here, it will end us, it will end our life, it will end our business, right? So it is very important to have good developers on the team, which we do, right? So the custom business logic comes on this layer. The stack, backend stack of Node.js, Mongo database, all of the centralized systems. Even here, blockchain has not come into the picture. All of that comes in the middleware. Going a step further comes the compute part of it, where the transactions will be computed. Like this is the computation that will happen here. For that you can use any kind of framework or blockchain technology. I have written here Ethereum. You might be having this notion that Ethereum is a public blockchain, but as I said, when Frank asked for an example of a private blockchain, you can take up Ethereum and you can create a private network on the Ethereum network, right? It does not have to be that public Ethereum network. It will be your version of Ethereum network, because Ethereum is nothing. It has a virtual machine called Ethereum virtual machine, and it processes the transactions. Now Ethereum is running that kind of a virtual machine in the public blockchain that they have built in such a huge amount. You can take it and you can set up a private network of it. You can set up a permission network or an enterprise network of it as well. So that is it. You can use EVM, you can use Quorum like we did. Quorum eventually again uses Ethereum. So it is one and the same thing. Ethereum is one of the popular platforms to create a private or a permissioned network as well. On the other hand, what you can do is this is something how you can create a blockchain in your own setup. You don't have to make it public. You can have one of the servers. Your clients can have one of the servers, and both of you have the instance setup of your network, blockchain network, and you connect to that same network. This creates a network. In our case also, this is how it happens, right? We might have 3 banks. We have 1400 warehouses. So what happens eventually is that warehouse network node is different. That is connected to world node, that is connected to the bank nodes, and this is how we form a private permissioned network. But it is not public, it is not available to the outside world, but the stakeholders on this network can see everything, right? Again, there also we can prevent people from seeing everything, but that is how it is now, and this is how we have set it up, right? They are and these nodes are in their individual AWS instances. Our AWS instances has the world node, the warehouse has a different instance, the bank has a different instance, they are just a part of the same blockchain network, right? How to do that, it is totally technical, maybe covered some in a very deeper lecture, but that is how a blockchain network is formed in its core sense. As already discussed here previously, storage can be on IPFS like a system which is distributed, or it can be on AWS S3, which is totally available to everyone, has nothing decentralized to it, but it is good to go. You can use storage for that. Yes. Any question now? I have covered a major chunk of what is important for you. Any questions? Otherwise, we'll move forward to here. Incentives. No questions? Anyone can unmute or ask, or I was expecting some questions because we have covered a great deal of concepts which are very important to you particularly, not blockchain in general. The last 4 or 5 slides were, I can tell you, that most important for you. If not, I'm happy to go ahead. All right. But again, if there is anything, Frank, Kevin, anyone, please do write in the chat and I'll pick it up just after this slide. So let us take okay, great. Thanks, Kevin. I hope all is clear then. So let's take a look at the incentive mechanisms that we were discussing earlier, right? So in this particular slide, we discussed 2 kinds of incentives that people have, miners have, and in turn also discussed that 2 kinds of attacks that can happen in the variety of networks. First of all, we have discussed ample now. Let's skip through it quickly. It's value gain. Just in a public network, which is the common case in the case of networks like Ethereum, Bitcoin, where after mining you get a set of reward. So in the case of Bitcoin, you know that the value gain for that miners is the 6.25 Bitcoin reward, which is humongous in amount, right? Also, something else is that, as I said earlier, that from the memory pool of transactions, miners usually order them in a fashion which gives the most transaction fee associated with the blockchain, with the transaction. Sorry. Any transaction fee that is associated with a transaction, it is totally pocketed by the miner. So all of that you get. As a miner, you get all of that. So that is the value gain you get out of a public blockchain. When we are talking about a private blockchain or a permission blockchain, there is no value gain, right? If one of my banks is mining on my network, which they are also part of, I cannot give them money in return. What happens is that the goal of this such kind of a permission network is to arrive at a common solution, or solve a particular problem. For example, let us make it clear by using an example. In our case, that example is giving the farmer a loan against their commodity in record time. Earlier, which used to take 10 days, 8 days easily, now with our blockchain implementation platform, it has reduced from 10 days to 10 minutes, 15 minutes. I can tell you, just 3 days back, I wrote in one of our WhatsApp groups that a farmer got loan within 15 minutes of an application. The farmer calls in that case and tells us that earlier my father used to do this. I have been doing this for my entire life till now, because they have been generational farmers, and they've said that every time 7-8 days were minimum. 15 minutes to get a loan in my account, and that too without the need of visiting the bank. Earlier they had to visit 2-3 times the bank. Now they are sitting at their home from the comfort, and they are getting loans within a few minutes or hours. This is something revolutionary. So that is what blockchain is doing for us in our case, right? So yeah, that is one example that I wanted to give. So for us or for the banks on a platform, this second type of incentive mechanism, which is TAT gain, TAT is turnaround time, the time it takes for us to deliver the service to the customer. So the bank would also want that the turnaround time reduces, right? So they are happy in giving out loans in 15 minutes as compared to 10 days. So this is the kind of goal that they want to reach. Yeah, is there a question? Someone unmuted in between. Is there a question? Then please write in the chat, or you can again tell. Otherwise, I'll go ahead. All right. So next part is that now let's take a look at some of the negative effects, some of the attacks that can happen on such consensus, such incentive mechanisms. If nodes come together, collude and attack or manipulate the consensus, in that scenario, illegitimate, invalid transactions will pass through. That will bring harm to the network as well as the blockchain, as well as the nodes that are a part of it. right? So if nodes collude, and if entities and certain entities and nodes collude and manipulate the consensus, it might mean a financial gain. How do they do that? Any loan transaction, they just pass off which is their own. It is very difficult to do. It can be done only in certain conditions where the number of nodes is very less, 3 nodes, 2 nodes. In that scenario you can do it. As I said very earlier somewhere in the slide, if you remember clearly, that it is good for whenever the more the merrier. So if you can see here that I don't think this was the slide, yeah, but there was a slide, if you remember, that the more the merrier, right? So the more the number of nodes are there, it is always the more stronger that particular blockchain is. I don't know which slide that was, but I hope you remember that, right? Okay. Yeah, this was the second point here. The more the number of nodes, further secure the blockchain becomes. So it is difficult to do such a kind of attack. What kind? This kind of attack, doing this kind of an attack on a public network like Bitcoin with 20,000 nodes on the network is almost impossible. So this happens in very few cases. Manipulating data oracles, again not going very much into that, again going very much Frank, I'll just take that question in 1 second. Not going very much technical into oracles, but oracles are pieces of software which provide external data to blockchain networks. One-liner definition is this: blockchain networks cannot directly connect with the external world using APIs or something like that. For that, oracles are there in place which take external data from outside and push it into the blockchain network. That's it about oracles. So in case any system, any node, any entity creates problem with that oracle network, eventually that oracle network will feed wrong information to the blockchain. In that scenario, the blockchain network will perform differently. Smart contracts will run using incorrect data, and what will happen is that some nodes might gain financial advantage out of it, but the core concept of the blockchain will fail, right? Again, happens in very rare cases, but just even if it is remotely possible, I believe that it is good to discuss, right? Okay, before going ahead here, let us take Frank's question, which is how does Bitcoin price, how low, impact on the miners' rewards? Yeah, because of course it is a very easy question to answer. Currently, let's say when the Bitcoin was at $19,000, 6.5 Bitcoins would have been 6.25 Bitcoins would have been 6.25 into $19,000. Now it is $47,000. Huge number, right? Which is what we calculated. It is somewhere what, like $300,000. Correct me if I'm wrong. Right, so if we are talking about $300,500, $300 or $320 or $330,000, it's a huge impact. So I would love to do a Bitcoin mining now as compared to when it was $19,000, right? So better the price, that is more I get. I will still get 6.25 Bitcoins. See, try to understand. Why are miners still sticking to the Bitcoin network? When the Bitcoin reward got halved, it would mean that from 12.5 I went to 6.25. Now the mining reward I'm getting is directly half. I may lose interest in mining, but why will I stick? Because I know that the price will go up. So even if the reward is halving, the price goes up. Then that suits me, because I will still get more amount as compared to earlier I would have get 12.5 Bitcoins into $19,000. Now how much would that be? It would be around how much? I think 240 or so. But now I'm getting the same half of it, but I'm getting around $300,000, $350,000. Again, it is a better deal for me, even if it got halved. But I'm so much well in that, right? So that is one concept, right? So that is what I wanted to share. So that is how it affects the Bitcoin price affects the rewards. The more the merrier, right? I hope, Frank, that is what you had asked. Yes. Yeah. Okay. Thanks, Frank. All right. Going ahead, let me see the clock once. We are already 3:30 on the clock. Let us try to cover as much as possible, but we'll have to stop somewhere. Okay. Guys, let's do one thing. Let us, instead of going into generations of blockchain, which is also important, but we have to end this class. So in the last part of it, I'll skip and I'll go to use cases, because I believe that use cases is something that is going to be more useful. Do you agree? Can you please let me know in the chat? Or I have two options. See, we have 30 minutes to cover. We are anyways going above 2 hours, and I have a meeting, follow-on meeting, so I cannot stretch it much long. But I have two options. Either we can cover generations of blockchain, or we can cover this. We can cover blockchain and innovation, enterprise applications and integrations. These are the two topics. Can you please at least 3-4 people write in the chat which you want me to cover, and someone that will get most votes will go with that. But we have limited time. We have 30 minutes to cover. It is not left. It will be again shared in another lecture maybe if we arrange it, but we'll make sure that the knowledge goes through. Yes, please, guys, can you please write in the chat? Otherwise, I have no clue that what I should cover. Then I'll just pick one thing that I would like. Yeah, am I still audible and visible? Is anyone there? Frank, Claudine, Oddard, Kevin?
I think the enterprise application and the blockchain innovation
will be more relevant to them, right?
Yes.
Okay, so Frank, I just asked that whether I should cover blockchain innovation and integrations, or I should cover generations of blockchain. That was the only question. So Mr. Coyote has himself suggested that I think enterprise applications is something that we must cover. So okay, great, thanks Frank. So in generations of blockchain, I had almost 12 slides. Good implementations, Ethereum, Bitcoin as well, but again we'll have to keep it for some other day. We'll go with this, right, as much as possible. Okay, perfect. All right, okay, done. All right, let's continue with this. So what I have here is we are straight jumping into some relevant applications that have happened in the world, and this is what, based on what you can understand that what other people are doing in blockchain, using blockchain technology, to maybe somewhere you can connect that what is it that you should be doing, right? Or where exactly your thoughts will open up, that where exactly you can use such blockchain technology for such use cases. Let us take a look. And we'll take a look at one example which I discussed earlier. I said that we'll come back to this, so I have 2 slides. I won't skip them. Let us take a look. We had discussed earlier that the reason why Bitcoin or such cryptocurrencies cannot be used as currency across stores, regular stores, and things that you buy. Let us take a reason why. So if you take a look here, let's do a comparison of transaction per second, right? So when we are doing a comparison of transactions per second, you can take a look on the screen. Massive difference between the kind of capabilities that we have. A Bitcoin, based on the 10-minute average block time, is calculated to have around 4.6 transactions per second, right? Maximum 7. Ethereum has 15 transactions per second. Way better than Bitcoin, of course, but still 15 transactions per second, that's all. On the other hand, when we are talking about Visa is something we all know, we all use every day regularly. Every other platform has Visa integrated. All the credit cards are mostly Visa or MasterCard. So this kind of a platform has tested to be up to 1736 transactions per second. Can you look at the difference? And that is not enough. That is not just it. Visa has promised that they have tested their infrastructure to take up to 56,000 transactions per second. Massive as compared to Bitcoin or Ethereum or any such transaction or any such currency, crypto. So any day Visa has 380 times throughput as compared to Bitcoin. That is the reason why when we take a look at such an example, you go to a Starbucks, you cannot pay using Bitcoins, right? These are relevant examples now we are dealing with. These are exact real life things that you can or cannot do, right? So if any questions, please do pitch in. Would be the right time to answer when we are discussing that particular example, right? So you visit a Starbucks store and you want to pay Bitcoin for your coffee. You want to pay for your coffee using Bitcoin. What you cannot do is, why you cannot do that is because neither you nor the barista would know that how much is it that we are going to wait to get your transaction in place, right? So that is one very important part. That is one very important concept, and that is the reason why you cannot still use something like Bitcoin or Ethereum to pay for your coffee or to pay for in a general store, departmental store, and so on, right? because you exactly don't know how much you'll have to wait. So if you visit a blockchain explorer, any blockchain explorer, I told earlier as well, just visit any blockchain explorer, blockchain.info or any of them. Go to Bitcoin or Ethereum Explorer. These are all public. We have discussed, I think this is one thing that I've said throughout the lecture, that this is one practical thing you can readily do right after this lecture is over. Go to one of the such explorers and take a look at how the blocks are being created, and where exactly the knowledge that you got from this lecture, how does it exactly relate, what things you can find there, and you'll understand that the time that it takes to create a new block, it is there. You can see it. You can understand this very example of why you cannot pay for your coffee using Bitcoin. So that is very, very important. Do take a look after this class, please. Frank, Mr. Kevin, everyone, please do take a look at a blockchain explorer. This is one thing that I have said since the beginning, because in core blockchain concepts, in these use cases, everywhere one thing has been constant, is that you need to take a look at a blockchain explorer to understand how things are going and moving. Correct? So that is one very important thing that you must take a look at. In fact, let's do one thing. If we still have time, what I'll do is, I won't leave it to you guys. What I'll do is, I'll let me see if we have time. We'll open a blockchain explorer here itself during the class, and we'll try to understand these things, what we are discussing now, what I'm telling you to take a look at, right? If we have time, we'll do that. Okay, let us do that in a moment, right? I think that would be a very important thing to understand how exactly blocks are being made. Something that almost 60% of the people I've taught, this is exactly where they go wrong. This is exactly where they get confused, right? So we will open a blockchain explorer. If needed, I'll cover a couple of use cases and I'll quickly go to that. Okay, so yeah, so summing it up, this is how the scenario looks like for blockchain based currencies and Visa in real life implementation. Stark difference between capabilities and the expectations out of those particular blockchain networks, right? In general, Visa has to only process payments, and that to 1:1. You do a payment, your acquirer bank, and you are the ones doing the payment, and Visa network is just facilitating it. That is all. Nothing else that Visa needs to do, and it can do so well that it is doing 1736 transactions per second. On the other hand, Bitcoin has to use a decentralized network to carry this out. So even if that is about one transaction between me and Mr. Coyote, for example, Bitcoin network has to communicate this transaction to 10,000, 15,000, 20,000 nodes easily. I mean, the exact number is not known to the letter, but it is more than 10, 15,000. And every node has to be communicated that Abhishek gave 1 Bitcoin to Mr. Coyote. That information has to be communicated. It takes time. Updating these ledgers, it takes time. And mining a block takes time. All of this is how blockchain works, but it takes time, right? So that is why you cannot pay for your coffee using Bitcoin. On the other hand, further worrisome part is that something like Ethereum is a generation 2 blockchain. Bitcoin is generation 1, Ethereum is generation 2. Sadly, we could not cover generations of blockchain. Otherwise, these slides would have made more sense, but it's nothing much. We'll set up maybe another lecture or something, and we'll make sure we do that. So Ethereum as a generation 2 blockchain was not only a currency of itself, which is Ether, which is you get, and in addition to that, it brought a revolutionary concept to blockchain networks, which is what is being used widely across the world. This concept of smart contracts. We won't have time to cover smart contracts, maybe later someday. Smart contracts are just pieces of code which run on the blockchain network, and that is exactly how you can realize that these new kinds of decentralized applications are running on blockchain networks. So Ethereum has to take care of those transactions that are happening, and also it has to take care of the massive data exchange that is happening because of smart contracts. Smart contracts are running, pieces of code are running on the blockchain network. That is why it is further, it is also slow. It cannot be like Visa. Big concept. I'll cover 2 or 3 maybe use cases, and I'll straight away go to the blockchain explorer, because just it occurred to me that I believe it is very important to take a look at. See guys, we cannot do anything. Blockchain is a vast concept. It has taken days and months for people to understand just bits and pieces of blockchain. We cannot sum it up all. Even if I want to deliver, we cannot sum it up in 2.5, 3 hours. It is just not possible. Otherwise you won't understand if I go at that speed. So I'll try to cover as much as possible. So that's why I had all the slides in here, but again, there's a limit to what we can cover. but yeah, most of the important parts we are trying to do it in this class itself. So let's take a look at this particular use case. Very short, we'll discuss in 2 minutes, but you'll understand where a big company like IBM has used blockchain, right? What IBM has done is basically it has you can say it has put the entire supply chain right into using its food trust blockchain. Combination of technologies used are blockchain and IoT. IoT is very much implementable in supply chain areas, supply chain problems, and they've used a combination of both these technologies and put them on the food trust. I think I've not written the name, but it is the food trust blockchain. If you want to go ahead and search, this is the keyword you should remember: IBM food trust blockchain. And this is what they've done. They've put the entire supply chain on a blockchain network. The goal ultimately to do this case, so if someone is into supply chain management or trade finance or something, you can relate to these examples. That is why I've chosen these particular 3-4 use cases, that putting a supply chain on blockchain network, the goal eventually is to make it very transparent to the end user, to the customer, of the entire process that happens to the customer's food. If it is any food, say for example, if it is your noodles, I mean, where was it manufactured, which factory, which area, or if it's your coffee, which location was it grown, sown, then where did it go, where it got manufactured, which dealer and developer got it, when did it come into transit, and finally it got delivered to you. You have a clarity of this entire process. That is the reason why supply chain management would be done using blockchain. One very, very good use case done by a very prominent company in the world. Do take a look at this. If this 2 minutes might not do even justice to such a kind of a use case. They have an entire document on this particular use case. Just go and read it if you feel the need. Yeah. Let's take a look here. Okay, I'll put it here. Okay, so right, so another use case that I wanted to share is that of insurance. Accenture, another big company, has researched this. Even though I was in the insurance field previously, but we were not using blockchain. But I can also personally vouch for the kind of massive potential that insurance has once put on blockchain, right? So that is what Accenture tried. They tried to unlock the value trapped in claims process, insurance process, and all of this that go into settling an insurance, and put it on the blockchain, use blockchain technology for it. Eventually, what they found is that they can use this use case used a combination of blockchain and IoT to implement supply chain management in food supply chain. This particular implementation uses a combination of blockchain, IoT, artificial intelligence, sensors to determine car accidents and so on and so forth. Then oracles, which I said earlier, that these are the pieces of code which give you external data. All of this come together to implement such an InsurTech example on blockchain, and Accenture has found out that maybe the savings, right, or the annual savings from such an implementation can be massive, from up to $100 million to even $200, $250, $270 million. That's a massive save for any kind of insurance platform or company or InsurTech organization. Big use case, and that is something that a company like Accenture has done. Again, this is what could be put in a lecture, but you can go ahead and take a look at the Accenture document. I have read this document. I can tell you that this is a very good use case. I have not put any use case on this in this lecture without going through the use case myself completely and understanding whether this use case is actually good or not. These are very beautiful use cases that have been done on the blockchain networks. Here I would like to stop, even though the next use case is mine. It is my use case, but I will not discuss this because I really wanted this is my use case, just to give you a glimpse. We are doing great stuff using blockchain as well, but I am not getting into this. This is my own use case. I would love to cover this, but maybe someday else, because I believe that this is the place where we have to go back. We have to take a bit of a sideline, and we have to, in the remaining minutes, we must take a look at a blockchain explorer. Otherwise, all the concepts that I shared earlier from the beginning of this lecture, 2 hours worth of concepts, might go really subpar or waste, right? So I really want to visit the blockchain explorer. That's why I'm leaving my own use case without telling it to you. So believe me, blockchain explorer is really important, right? So let me go there. Let me share. After that, I think we'll be okay. So we'll I have a few more slides. I have one more use case on Estonia. You can see. I have after this, something that I wanted to give out is how you can build a career in blockchain technology, but we are short in time, so I'm skipping these. But eventually we will want to do, right? Eventually we would want to do this someday, right? But not today. It is not possible in 2 hours. So we will end it here. Let me share the screen to Safari once, so that we can open a blockchain explorer and see in the last few minutes. Okay, cool. Yeah, is the browser visible? Can anyone tell me, is the browser visible? No.
Not yet.
Okay, cool. Yeah. Then let me share it. 1 second. Okay, yeah. I think I understood what the problem was. Okay.
So you can minimize the PPTs.
Yeah.
All right, it's okay.
Now it's visible, right? Perfect.
Yeah.
Okay, cool. Great. So let's take a look at what I think. Yeah. Yes. So one of the explorers is blockchain.info, right? I could have put a couple of slides on this as well to even share it on the slide, but again, this was not planned, so we are just doing it live, whatever we get in hand, and this is not prepared from before, but I will do justice to it. We will have ample knowledge to share here. So let us take a look at it, whatever is going live, right? And whatever we learned, remember that anywhere you face a doubt, now is the right time to ask. So now you can see, I believe that you can see, yes, Hoddard, please remember to share the slides. I will definitely share the slides. Till what position we have done today, I will definitely share the slides. Okay. All right, let's take a look at this. This is one blockchain explorer. There are plenty of blockchain explorers available all across on the web. You can just go ahead and take a look at it. One good thing about this blockchain explorer is, just give me a second. Yeah. One good thing about this blockchain explorer is that you can change from a Bitcoin explorer, it is hanging a bit, to an Ethereum explorer. This is where, one place, or even to a Bitcoin Cash explorer. So these are the different explorers that this one website provides, right? So or even there are some Bitcoin explorers separately as well. It is very easy to build one because all are public and it is not a lot of headache to do so. Let us go down and let us take a look at the first piece of information that is there. We are currently seeing things in USD. The first piece of information you see here on a blockchain explorer is the current price of the Bitcoin of Bitcoin, which is currently 46,500. So a very good thing happened just last evening when I was giving a slightly more technical lecture to one of the management institutes in India. And what happened was that in the evening itself, around noon for you, we opened this blockchain explorer. We looked at the price, which was very interesting, which was exactly 40,000 some dollars at that time. We scrolled down. We did a discussion of blocks and transactions for 5 minutes, 6 minutes, 7 minutes max. We scrolled up, and immediately it was 43.5 or $44,000, right? So that is something that shook the entire class, because we were already discussing about the volatile nature of Bitcoin, and immediately within 5 minutes it went up by 3,000, 4,000 US dollars. Big rise. And later I got to know that it was because at that point in time Tesla and Elon Musk had invested more than $1.5 billion in Bitcoin, right? Yesterday at that very time itself, and that is the reason why during my lecture we saw such a hike in the Bitcoin price right within just scrolling on the page. That is how live these things are, right? Okay, great. Okay, I see from Kevin is that he has written that to see you is better. Is it because my video is not visible now? Is it something like that? I could not understand. Otherwise, if it's a compliment, then I'll just take it. Let me know if there are any issues in sharing the screen, and I'll rectify it. Okay. So and thanks, Kevin. Thanks a lot. So we see it here. One very important part we see here is the next data point, which is the estimated hash rate, right? One second. Okay, cool. What we see here is the estimated hash rate. This is what I was talking to you about when I said that you take create a block of transactions as a miner, and then eventually what you do is that you solve a cryptographic problem. But the only way to do so is by solving it using the hit and trial method. When you do so, you try millions of hit and trials per second to arrive at the solution. This is that hash rate, the number of hashes that you have to do per second to arrive at the solution. This has become so humongous right now, it is not capable by a laptop or a desktop computer to do this kind of a hashing per second. We can see a very good factor here, which is the number of transactions that have happened in the last 24 hours, which is 358,000, right? And this varies. Last evening it was 292,000. I remember this is 358,000 in the last 24 hours. Then from now, so it keeps on changing. Then there is transaction volume changed. Then there is transaction volume in estimated BTC changed, and all of this data is there. Going down a bit, of course, you can see the price, how it has moved. It was hardly anything, 39,000 here, and then it just went up yesterday, and one day it took to increase it by 25%. One very important concept which we discussed the first in our lecture was this mempool. You remember we talked about a mempool where we said that the number of the transactions are first go into this mempool, and this is from where the miners pick up transactions. So this is that mempool, and you can see that the number of transactions at any point in time, say for example 12 p.m. today in my time zone in IST, 12 p.m. it was 78 million transactions that were there in the mempool, and miners are constantly picking these. So it's not like that you have to wait for an entire day for your transaction to go through, right? Coming down, let me see the clock. Okay, yeah, we have some time. Just one second, please. Okay, so this particular thing that you are seeing on the screen right now is very important. Blocks is something that we discussed quite a lot in our initial explanation, that how a block is formed. This is that block. This is where I'll tell you the example that we just covered, that why you cannot pay using Bitcoin to your Starbucks cafe. I'll just tell you that. On the other hand, the latest transactions that are happening, a very important concept we'll cover here, and we'll be done with it. We'll be done with the class, and that's all to pay attention now. This block height is what you are seeing. This is exactly, and this is all real time. You can see things moving on the screen, right? So, and that's how a real time blockchain network is. So this block height is what is the latest block that got formed. So you can say that 669,831st block was created just now, right? It's 16 minutes ago. It was created by a miner who is unknown right now. That is the whole concept of blockchain. You can be of a public blockchain. So Frank asked that question, that what is the difference between public and private and permission? In a public blockchain, you can be anonymous, right? You asked a question for anonymity. You can be anonymous in a private blockchain, in a public blockchain, and no one will get to know ever, right? Similarly, if you wanted to be if this unknown miner had to be a part of a permissioned or a private network, they would have to reveal their identity, because someone becomes a part of a private or a permissioned blockchain only after the blockchain who handles the blockchain approves that addition of a node, right? So that becomes very important to take care of. But in this case, the miner is unknown, and no one knows exactly who is the person who built it, because they don't have an ID in front of them. The size is just the size of that particular block. It totally depends on the number of transactions. If there are 15 transactions, the size would be different. If there are 8 transactions, the size would be different. There is a technical concept attached with this. People wanted to increase the size of this particular Bitcoin block, and hard forks have happened regarding that. People wanted, initially Satoshi Nakamoto said a block should be 1 MB in size. Later people did a hard fork to increase it to 4 MB, then got back, and a lot of things happened. But hard fork, soft fork, all these are some technical concepts that we can I don't even have slides on. We can cover in a separate technical lecture for that matter. But again, or you can take a look at on the internet. But then hard forks are related to this, when people want to make such protocol level changes. Important part. Very important clue here is that take a look at when the block was mined. 16 minutes ago from now. another block was mined 16 minutes ago from now. So that means that both these blocks, 30th and 31st block, were mined exactly around the same time, that is 16 minutes ago. That means the transactions between 30 and 31 didn't even take 1 second or 1 minute or a few minutes to be confirmed on the Bitcoin network, right? So now can someone please chip in and tell me that from here, you tell me that why is it that we cannot pay? Everything is there on this particular screen. Your answer is there. Can you tell me just the thing that we were discussing earlier, that why cannot you buy coffee using Bitcoin right now in your Starbucks cafe? Can just someone come, just unmute and tell me why? The example is in front of you. The answer is in front of you. Can someone please unmute and tell? And all of this is live data. No one? Frank? Kevin? What do I have? Come on, if it's not being useful in that scenario, then the explanation would not be good. Hodard? Claudine?
Repeat yourself so that clearly some people can hear.
Yeah, yes, Mr. Coyote?
So probably you should repeat yourself so that
Okay.
they can understand
Sure.
and hear what you just said.
Sure. So what I'm saying is that, can someone please come online, unmute themselves and tell me, looking at the screen, why just the example we discussed some time back, that why you cannot pay for coffee in a Starbucks using Bitcoin? The reason why, the answer is here on the screen. Can someone unmute and tell me that what is the answer? What is the reason why you actually cannot pay for yes, Kevin, I see you on video. Would you like to tell me that why is it that you think? Let's try to interact and try to analyze what you see on the screen. Why is it that you believe I cannot go and pay for coffee using Bitcoins right now? Why is it? Answer is there on the screen. Can someone tell me, please? That is my question. I believe it's clear. I'll wait for 30 seconds, else I'll take it up myself, of course. But I would then want to understand that is there a problem in explanation? Come on, Frank, you were asking so brilliant questions. Any clue to this?
Okay, thank you. I think the reason why I could not go to the restaurant and then take coffee and then pay using Bitcoin is this issue of confirmation, transaction confirmation, and the time it will take. Because
Exactly.
when I look at the latest blocks, I can see that
Exactly.
the time taken to confirm the block is 16 minutes.
Yes.
16 minutes, and then 17, 19 is 44. So I think it's a bit a long time to
Right. So
really
exactly.
sit down and wait.
Right, very right. So exactly as Frank said, that is the answer to this. If you would have known, so one big point here is that if you would have known that it always takes 5 minutes for a block to be confirmed, say it would have been 5 minutes, 10 minutes, 15 minutes from now, like that would have been the order, then at least there would have been a possibility that the Starbucks barista knows that I will have to wait for this gentleman's order to come through. I will have to wait for 5 minutes. You would know that. But in the case of Bitcoin, it can be 1 minute, 2 minutes, 5 minutes, or it can be 40 minutes. You can see one block got created 44 minutes ago. The next block next after that got created 19 minutes from now, right? So there is a difference of 25 minutes between this. So the difference in time between block 27 and 28 was 25 minutes. If you calculate, I hope I'm not calculating wrong. It is 25 minutes here. 28 and 29 is 2 minutes. 29 and 30 is 1 minute. 30 and 31 are same. And now again, if I refresh, it might seem that okay, sometimes some other number has come. So it is uncertain. It is not certain, right? The only reason we cannot pay using Bitcoin right now is because the Starbucks or you would not know how much should we wait. Should we wait 5 minutes, 15 minutes, 45 minutes, 1 hour? How much exactly should I wait? Because it can anytime get confirmed, right? Or it can make you wait for a long time. So you do not know how to pay and how much to wait. In the case of Visa, that does not happen. You know that within a second your transaction will go through and you'll get your coffee. So that is one reason. That is what I wanted to show live. The reason why you cannot use blockchain or to use Bitcoin or Ethereum to pay for your coffee at this point in time, or pay for anything in life. You can use Bitcoin to pay for online things on online websites, because there you are not waiting in a queue. You know that, okay, if I'm doing a Bitcoin transaction now, I can wait for even 40 minutes and it get confirmed. I don't care. You can take 1 hour. I will not worry, because I'm not standing in a line, right? But if you're going to a physical store, you cannot wait for an X amount of time and without knowing that exactly what that time duration should be. That is one big reason to actually not be able to pay using Bitcoin. Another important part I wanted to show here is the transactions part. This is the hash that you're seeing. Yeah. Yes. Yes, Frank, please tell.
Small question. There is some shops where you can get cross and they written that Bitcoin are accepted here.
Yeah.
So are those the people at risk concerning their businesses, their payments, part of it using Bitcoin,
Right.
or is not advisable?
Right. So the people who are trying to do this, they are willing to wait and they are offering a service. So they are not offering, for example, food items or things where, you know, they are willing to wait for that amount of time, uncertain amount of time. But again, that is very dicey. It is not widespread, right? For example, examples like Starbucks are very far away from using Bitcoin because of the same reason. And also, sometime back in India, someone set up a Bitcoin ATM in one of the cities. Overnight, he was picked up and put in jail. So this is one of the reason that why Bitcoin as a transaction has not taken a lot of pace till now. So thank you for the question, Frank. That is the reason why exactly. I have a question here that why it has to take. Okay, so Jean, I'll take your question and I'll take Frank your question in a minute towards the end when we are anyways ending. One important point I did not want to miss here, which if I just forget, is take a look at the transactions here, please. The transactions that are being updated. This is what the transaction hash looks like. You remember, I'll open a slide. You remember a slide where I had left a fourth point, which was just, Merkle trees and unhackable truth of blockchains. That is exactly what it is related to. We'll cover that in a moment. It is a deep technical concept, but we'll try to make sure that we do it. So if you visit this in a second, just 1 second, let it open. So this hash that you are seeing, this hash is a hash, a checksum or a hash of all the transactions in that particular block. A very interesting part of blockchain, the reason why blockchain is immutable, the core concept, please listen to it very, very carefully. We are almost done. I understand it might have stretched really long. It might have got boring as well. I hope not. But last concept, please, an important concept of all. The reason why the core concept of blockchain transactions being immutable, this is the reason why. Only this. You can see it on screen. Everything is so public and live, I can tell you right now. This hash is formed using all the transactions of that particular block. And another additional interesting thing about this is that the next block that is going to be made will have this hash in them, in their own hash. Similarly, this hash has a part of it in the previous blocks. Hash is a part of this hash also. I did not want to cover this topic because it is a bit technical. People go really crazy and confused when this hash and that hash come into picture. But this is the reason that every block is interlinked. If you go back and you change or try to change a transaction in any of the past blocks, what will happen is that this hash of that block will change, which will imply that because this hash was a part of the next block's hash, hence the next block's hash will change, and so on till the end will change, and people will immediately know that there is some problem. Someone messed up with some block because of which the hashes are not matching anymore. Right? So we have some hash and the hash should be something else. The match, there is a mismatch, and that is what tells the network that there is some mess up with the blockchain, and that is when people call out. That is why in standard systems, in everyday centralized systems, when frauds happen, when scams happen, people get to know these when governments are in scams or private companies do frauds and scandals. People get to know this years after the scam has happened, right? When it comes out. But in the case of blockchain, immediately you can get access to what happened exactly, and other nodes will call it out. That is the power of decentralization. That is the only reason what we started our lecture with, that why decentralization, and that is where we will end this lecture, that this is the reason why decentralization came into picture. It is the answer to all such malpractices, all such frauds, scams, corruptions, scandals, all such kinds of things that happen in the world across all the countries. Every country has some scam or scandal or fraud of their own. This technology is an answer to them. Simple concepts like hashes, like blocks, like things like this are answer to immutability, hack-proof nature, transparency, anonymity. These words I'm telling you again and again so that you have them in your mind. These are the core words related to any blockchain, be it a public, private, permissioned, Bitcoin, Ethereum, any blockchain, world, quorum, anything. The core concept is this, and these are sufficient in helping companies and governments and organizations prevent massive millions and billions of dollars in frauds. We have built our entire business on it. I could not cover my case study, my own case study, otherwise I would have told you there. We are working with governments and banks, and we are saving millions in dollars in frauds for those banks, right? So that is where I'd like to leave it, because this is the core of it. Won't go into technicals much with the hashes, but just understand that this is all this is why decentralization came into picture, why you should use decentralization. I'll be done with this, and I'll go return back to my PPT, and I'll take up the questions, and we'll be done there. 1 second. All right, great. Yeah, so let us take the questions, and that's done. Okay, before we take the questions, I've given you 2.5-3 hours now. One request, please do give this feedback, which helps me improve the delivery next time. It really takes you 10 seconds. It's completely anonymous. You don't need to insert your email, name, age, date of birth, anything. You just have to say that whether the lecture was good or bad. If it was bad, if you're voting anything other than 5, there is 1 to 5 rating. If you're voting anything other than 5, I would request that you fill, there is another input box. I would request that you fill the reason why you voted it 4 or 3 or 2 or 1. If it was that bad that it got a 1, 2 or 3, definitely do please tell me what was bad, so that we can deliver better for the next anywhere I give lecture to. So I put it in the chat. I would request everyone to please open the link and give. You're just 7-8 people, including Mr. Coyote. If you believe there is a feedback to share, please do write. It is an anonymous feedback. I would love to have that. Now I'll surely like to take questions. I put it in the chat. So I have 2 questions here, and in addition to that, I'll go to this last page. It has my credentials. I'm accessible via Africa Blockchain Institute. I'm accessible via LinkedIn, WhatsApp. Best case is WhatsApp. Always will receive an answer from me. Any problem that you face regarding blockchain technology, happy to answer anytime. All right, let's take questions. So is volatility bad or good for BTC community and the fintech part of it? Volatility is very bad, Frank. I have a direct answer to this. Volatility is okay. I've left one question, but Gene, I'll come to that. Sorry. Volatility is very bad because people get devastated because of this kind of volatility. People are trading. A lot of people are not investors; they're traders. What they do is they buy low, sell high, and try to do that. But even in our general stock markets, right, in our own countries, even when those markets are hardly 1/10, have the 1/10 volatility as compared to Bitcoin and other cryptocurrencies, even in those markets people lose such kind of money, right? So what happens eventually is that when people enter BTC and this fintech community, they try to do the same trading and they lose further more money. So I would suggest as a disclaimer, no investment advice. But one advice that I can definitely give is that do not enter BTC trading or investing and this community unless you know exactly what you're doing and you have some throwaway money to put aside that I'll put into trading only and only. If I lose it, I have nothing to worry about. That's what I have done in the past. But make sure you don't use your life savings and put it into BTC. I mean, again, your call, but would be an advice. Again, no investment advice as a disclaimer. So Jean Claude had asked that why it has to take that time to be confirmed. So as I said earlier in the lecture, the entire mining process, the entire block creation process, Gene, that that it takes a lot of time. You have to do millions of hashes per second to arrive at that solution, which tells that you have done the proof, you've shown the proof that you have worked to find that solution, and now your block is sufficient to be added to the blockchain, and we can give you the 6.25 bitcoins as reward, right? So this entire process takes a lot of time. That is why blockchain networks are slow. That is why when proof of work or such consensus mechanism, good example here, thank you for asking this question, it will clear for everyone. That is why when we are talking about not public blockchains which are permissioned like ours, we don't use proof of work, right? We use a consensus mechanism called Raft. In that scenario, the mining takes place within seconds, 2 seconds, 3 seconds, 4 seconds, and that's all, 9 seconds, that's all. So in that scenario, the transactions per second is very fast. So if you use our blockchain and do a transaction, maybe buy a coffee, you will get it within 9 seconds or 10 seconds, right? Similar to Visa. So if you remember a slide I showed, that in case of private and permissioned blockchains, the transactions per second is very fast. In the case of public, it is totally a different ball game, and hence it has to be very difficult. It takes a lot of time to do that mining. That is the reason. Please, John Claude, let me know if this answers your question. If there is a follow-up question, please let me know. Happy to take it up. I have answered Frank's question on volatility. Then I have one from Kevin, which is which minimum value for entering in blockchain. There is nothing as such. You can enter with anything, right? In India. So if you're talking about blockchain, it's different. If you're especially talking, I mean that then this question is a bit irrelevant. But if you're talking about Bitcoin or Ethereum particularly, then it depends on your country and which are the apps that you have in your country. In our country, it is very, very low as well. You can invest very few Indian rupees, and you can start in investing or trading. So nothing as that, Kevin. I hope I answered your question. Was this your question, Kevin? Please let me know if I've understood your question right, that the minimum value for entering in blockchain. And also, if you're thinking of implementing blockchain in your startup, then this value does not even come into this money factor does not even come into question. What you have to think is that whether you have a use case that can be attacked using blockchain, right? So John Claude, don't worry, I'll be sharing the slides of the PPT which have been covered today in the lecture with Africa Blockchain Institute. They will definitely share it with you. You can get in touch with Mr. Coyote because I don't have your individual emails, and if you have follow-up questions, you can post them back to Mr. Coyote. He gives it to me, or my credentials are there I hope you're able to see my LinkedIn and my email and my WhatsApp number. I hope they're visible on the screen. That is what slide I have opened now, right? Can someone please confirm? If you can see my LinkedIn and my WhatsApp, you can reach out to me on WhatsApp as well. It is very, very, I'm happy to help any place. So either via Mr. Coyote, directly with me, you can get in touch. Blockchain knowledge will always be given to you. Do not worry about that. Okay, and I don't have any other questions. Yeah, so I'll be happy to end it here if I don't have any other questions.
Thank you very much, Abhishek. I mean, it's been a long time. I mean, working with you, I mean, this lecture was so deep and well prepared, and I'm sure the candidate as well, they totally value your time and your effort to make us understand, at least at best, in terms of foundation of blockchain technology. I mean, you have gone through the length and the breadth, the crypto aspect, the other use cases, agriculture, and several other important use cases on blockchain to demystify the whole conception of people who might have about blockchain technology. Thank you very much.
Thanks a lot, Mr. Coyote.
So I'm sure you will learn one or two things today from Mr. Abhishek. Did we? Did we learn?
Yeah, Frank, Pauline, John.
Mike.
Okay. Kevin Hoddard, please let me know if it was actually useful. Yeah, some of the people have let me know on the chat. Frank is very happy with it, I hope.
Okay, cool. Thank you.
Right.
So that's good. And so one more thing is that I want us to go to the to our social media. I'm trying to share you some links. Just bear with me. Of ABI. So we could go out there and share to the some things that we have learned today from Mr. Abmesh to let the world know that you have gone through the training at ABI and also through the incubation program. I mean, it's going to make a much more better sense to let people know what is going on. And from there, I'm sure you even get to receive several connections and several referral, trying to understand what you are doing, trying to give you much support in what it is you are doing. So please, I've sent the our links on the chat group. Please go check on it, copy it right now, and go check on it and try to post at least one or two lessons you have learned today. And you can use the hashtag ABI program, and you can connect with Mr. Admishik on LinkedIn and also tag him as well on your post so that, I mean, from there, people get to know what it is you are building and people get to appreciate, what it is that we have been able to put so far. Please, I encourage you again, please go to your social media and get to post your lessons from today. Same thing as well. I encourage you to do similar thing from tomorrow's program. And for tomorrow, now it's much more the technical program. There you'll be needing to come, especially with your computer science technologies or a developer to come for tomorrow's program, because you're now talking fully about the blockchain development. Because this is a blockchain incubation program, so it's a combination of the basic business side and also technology side. So tomorrow, please, starting by 10 a.m. tomorrow, don't miss it, and try to make sure you come in time and you get to come with your developer, because that's the really best way you can get to understand what the teaching is all about. So thank you very much again, and please try to drop some feedback on the social media, and also try to drop feedback on Mr. Abmeshik's link that he dropped as well. And from there, we get to follow up. So don't forget again, also be active on the channel, on the Discord channel, to be able to get through on Discord channel, able to get the recent happening and different information as well. Very important you check the Discord channel every now and then to know what is happening and get in touch. So I think Mr. Jane, you want to say something?
Yeah, I want to say something. So I would like to ask, even though it is on my behalf, maybe my colleague may somehow have some problem like me. I want to know if we will be conducting all this program by 10 a.m. for this 4 months, or if we can adjust somehow for a convenient time, so that we can see how much time, or we can, I don't know if it is set by 10 a.m. every day.
No.
So could you emphasize on that, then we can see what...
Let me explain. So it's only this first week, this Tuesday to Thursday, that we're having 10 a.m. From next week, we'll be connecting with your mentors and your developers. So it's now left for each group to agree on a particular timing with you, your group, and your developer, your group, and your business mentor. So, but only this week is when we're having the 10 a.m. lectures.
Okay.
Yes.
Yeah, it is good if it is only this week. It's no problem.
Yeah, it's only this week.
Okay.
Can I ask some question?
Yes, please.
So we are agreed to be available every day, but if possible, you can take an hour of afternoon, PM, because still morning we still having a low connection because of accessible many people. And I would like to tell that one who presents to see him. It will be better, because when you hear only without looking on their mouth, there are some words which are going to be lost. Thank you.
Thank you. So from your last question, I think Mr. Abhishek also shared his screen. His camera was showing, so I guess you can see him. So I don't think there's a problem on that, but just that his screen was sharing his screen for us to see. But his camera was on as well, so we can see his face all through the program. Probably can try to adjust that from your end, so we can see him. So second thing is about the timing. As I mentioned, from today, tomorrow, and Thursday, is the 10 a.m. program. After that, there's no other 10 a.m. program except we communicate that with you. And again, is that tomorrow and Thursday's program or any 10 a.m. program that we have, we can't shift them because these guys are coming. They are actually occupied. I mean, they are busy in their country, busy in their business, and I know that you're also busy as well. And part of the reason why when we're trying to call you and select you, we confirm will you be available for some of this timing. So these guys that I won't bring in for the rest of the week, their calendar is booked. So we book them from 10 a.m. to 12 12 p.m. every day. So they have calendars since last week. So we can't now and change their calendar because that means we want to change their own schedule all over. So please bear with us and let us sacrifice this first week at all to make sure we have a very strong foundation. I'm sure the rest is going to be very flexible, as I mentioned. It's you and your mentor, you and your developer. You can decide midnight. You can decide anytime you want to agree with your mentor to work with. So thank you very much, Mr. Kelvin. So thank you again, Mr. Abhishek. Thank you very much for coming. I will also reach out to you. We have still a lot to discuss.
Sure.
Can you please make the Africa Blockchain Institute the host so that I'm able to conclude this program?
Yeah.
And again, guys, please don't forget to go to social media. I've shared it to you earlier. So please go back there again and share your point that you have learned today and put it there. And we can also go ahead and retweet it and get even much more connection for you guys as well. Thank you very much. And we hope to see you much more in the Discord group. Please, I'll also drop some information. The Zoom link for tomorrow as well will be dropped inside the chat by this evening or this afternoon. Thank you very much and have a good day.
Yeah. Thanks a lot, guys.
Abish,
Thank you for being a
can you make
wonderful
the Africa
audience.
Blockchain Institute the host?
Yeah. So I need to do it, is it, Mr. Kayode?
No, this one, the first one. Okay, the Africa Blockchain Institute.
Yeah. So I can click and I can make host, right? Yeah.
Yes.
Yeah. I just changed the host. Yes. You are host now, I think.
Okay, I think.
I can make you
Yes.
co-host as okay. No, now I can't do anything. Yeah.
Okay, cool. So, all right, thank you. Thank you very much. Thank you for all part of Kijana Rwanda. I mean, Mr. Kelvin, Mr. Odward, Claudine, Frank, thank you guys for taking time to come
Guys,
through.
can we,
I know
Mr. Kayode,
it's not easy.
Mr. Kayode, can we ask everyone to open the cameras once and we can take a snap or something like that? Is everyone comfortable
true.
with that?
Can we all put on our camera? Let me put on my camera.
Mr. Kayode, you as well. Yes. Yeah.
Can you see me right?
Nice to see you.
Yeah.
Frank, Hodard, John, Claudine.
Frank, can we
Come
put on the
on.
camera?
Perfect. Nice to see you, John Claude. I hope I'm pronouncing it right.
Jamie.
Claudine, Frank, it seems that you opened your camera, but then again, it's still blank.
Yeah.
Hodard, do you want to? Okay, anyways, all right, perfect.
Yeah.
Let's do this. All right, thanks a lot. Shall we drop out then? No, Mr. Kayode got stuck, is it? Yes. Mr. Kayode, shall we drop off?
Okay. Thank you very much. We'll see more guys tomorrow. And you can also reach out to me on the Discord and tell me and say if you got any problem. I'll be glad to make sure I answer them as soon as possible. Thank you very much, guys, and have a very good day.
Yeah, thanks a lot. Bye.